All right, welcome to lecture number 9. In this lecture, we're going to move on. And in the last chapter, right, we talked about atoms, we talked about elements. That was like the last chapter. So we're moving on to another topic. And in this topic, we're going to talk about combinations of elements. So another way of saying that is we're going to talk about compounds. Now, specifically, we're going to learn a lot about naming compounds. So what do you call compounds? What do you name them? And how do we do that? So this lecture is going to be divided up into 4 parts. First part is just a little bit about what a compound is, and then actually we're going to learn to name anions, which are a part of a compound sometimes. Then we're going to learn what do you call cations, naming cations. And then once we know that, we're going to be ready to start learning to name compounds. Specifically, we're going to learn to name ionic compounds in this lecture, and there's a lot to it. So there's going to be 2 parts to that, naming ionic compounds. All right, so with that brief intro, let's go ahead and get into it. Okay, so let's go ahead and get started talking about compounds. So when we talk about compounds, we've already talked about them previously, haven't we? So we talked about them, well, gosh, when was that? Back in the first chapter, I think, the first week. And we said a couple things about them. First off, we said compounds are 2 or more elements chemically joined together. So they're 2 elements put together. And we also mentioned that, well, the way you're going to know if you have a compound is that you're going to be able to see a formula. So if you have a formula, you can think of a formula, or you're told a formula, that's going to be a compound. So for example, water is a compound. The formula for water is H2O. So this is telling me that we put together 2 hydrogens and an oxygen. When those 2 hydrogens and 1 oxygen get together, we have water. Another example would be like table salt. Table salt, the formula for table salt, you might use it when you cook dinner or whatever, is NaCl. So this is telling me 1 sodium and 1 chlorine have gotten together to make salt. That's what salt is made up of. For every 1 chlorine, there's 1 sodium. All right, so a couple of things I want to tell you about compounds, and that is that it turns out when we have a compound, the properties of the compound can be really different than the elements when they're by themselves. So compounds can have very different properties than the elements when they're by themselves. All right, so let's look at a little example of that. So a little example of that would be like in salt, actually. Oh, let me flip over here. Oh, flip. There we go. All right. And so you might remember in a previous video, the last one, I think, actually, I did a little example with sodium, a little demonstration with sodium. And you remember how I put it in the water and it reacted with the water. It created hydrogen gas in the water. So sodium, when it's all alone, it's really reactive. And you can kind of see the photo right here. It has this sort of, I don't know, silverish, off-white color. So that's what sodium is like. Now chlorine, if you have the element chlorine, chlorine is actually a yellowish gas. So it has this yellowish gas color, and it's actually really dangerous as well. It's actually a poison. And so both of these, when they're alone, they're actually not that great to be around, right? One gives you one is reactive with water, that's the sodium, and it's like an off-color metal. Chlorine, when it's by itself, it's a yellowish poisonous gas. But when you put them together, you get a white solid that's not that dangerous, right? Sodium chloride is relatively harmless. Yeah, if you eat a bunch of it, right, it can give you high blood pressure, but that's about it, right? So that's what I mean by the fact that, yeah, elements, they have different properties than when we put them together to get a compound. And sometimes those properties are really hard to predict. Like, who would guess you put sodium and chlorine together and you end up with a white solid? It doesn't really look like either one of those elements when they're alone. All right, so with that little introduction to compounds, let's kind of get into really our main focus in this lecture and in this whole week, actually. And that is going to be on how we name compounds. So we're going to learn a lot about how we name compounds. And before we can even do that, I need to make sure you realize that there's actually more than one kind of compound. So we're going to learn about several kinds of compounds, and they're all going to have different ways that they're put together and different ways that we name them. So in this lecture, we're going to start off with ionic compounds. All right, so ionic compounds is our first category. You'll see other categories. We'll be talking about them in a future class. So ionic compounds, how do we know that we're dealing with an ionic compound? How do we know something is in this category? Well, the main way we know is if you ever have a compound and it's made up of a metal and a nonmetal, that is an ionic compound, a metal and a nonmetal. So, what does that mean again? Oh, do you remember we talked about how there's this staircase thing that divides up the periodic table? And if you are on the left of the staircase, do you remember what that was? Anything on the left? Anything on the left is a metal. And we talked about anything to the right of that staircase is a nonmetal. So in an ionic, nonmetal, let me erase that. In a ionic compound, you're going to have something from the left-hand side of the periodic table, something over here, along with something from the right-hand side of the periodic table, something over there. So as far as that goes, I've already shown you an example of a compound, actually. One example would be salt. Salt is an ionic compound, NaCl. Right, we have sodium from the left-hand side, that's my metal. We have chlorine from the right-hand side, that's my nonmetal. You put it together, that's an ionic compound. Now, another example would be something like, I don't know, we'll do calcium bromide. Calcium, that's a metal, left-hand side. Bromine or bromide, that's on the right-hand side. That's a nonmetal. So when you get a metal and a nonmetal together, that's an ionic compound. Now, as far as ionic compounds go, before we can really get into what we call them and naming them and all that, we need to learn a little bit more about ions. So this lecture, actually, we're not even going to really talk about compounds quite yet. We're going to learn just a few more things about ions, and then eventually we're going to get into compounds. So ionic compounds, well, the reason we need to know about ions is they are composed of ions. So let's start off learning just a little bit more about ions today. So let me get to the next slide and we'll do that. All right, so do you remember what an ion is? What's an ion? So an ion is just any particle with a charge, It could be something with a positive charge or a negative charge. If you have a charge, you're an ion. Now, today we're going to get a little bit more specific, and we're going to learn that there's some elements, they tend to make the same kind of ion. So for right now, we're going to start off talking about nonmetals. So nonmetals, when they become charged, they like to form negative ions, and negative ions are called anions, or called anions. All right, so any nonmetal, so that's the stuff in that top right corner, they tend to make negative ions called anions. And actually, I can be a little bit more specific than that. So I can tell you what charge exactly they're going to make. So group 7 on the periodic table, or group 7A, you might hear it called, this group right here, when it forms a charge, it likes to make a -1 charge. Usually we write the negative sign second, 1 minus. Now, if we go over to the next column over, the group with oxygen and sulfur and selenium, this group right here, the 6A, or you might hear it called the 16 column, they tend to like to make a -2 charge, 2 minus. If we go over to the group with nitrogen and phosphorus, this group, group 5A or 15, they tend to like to make a -3 charge. So anything in that column will make a -3 charge. Now, I should tell you that these charges, they are pretty much ones you can count on, all right? Now, as far as these particles, the way that we're going to let people know that they have a charge is that we actually change the way that we name them. They actually have a different name when they're charged. So to be a little bit more exact, we've been learning how to name atoms. So atoms are neutral. Atoms don't have a charge. Ions have a charge. So for example, we've talked about what you call F and what you call Cl and what you call O and what you call N. All right, you've learned the names of those symbols. So, but what do you call F when it has a -1 charge? What do you call Cl when it has a -1 charge, 1 minus charge? Or how about O when it has a -2 charge, or N when it has a -3 charge? Now, one thing I'll point out to you again, how did I know -1 or -2 or -3? I looked at where these things were on the periodic table. That the column numbers told me up there, right? So depending on what column they're in, I knew whether it was going to be -1 or -2 or -3. Now, when you're an ion, the way that we tell people that you are a fellow with a negative charge, their names will end in IDE. Their names will end in IDE. So let's do these examples. So you learned that F, the element F, that's fluorine. Fluorine does not have a charge. It's neutral. But when we have F with a minus charge, when we have that ion, F minus 1, we don't call it fluorine anymore. Oh, rats, I did it too early. We don't call it fluorine anymore. We call it fluoride. Got ahead of myself there. All right, so fluorine is the element. Oh, maybe I should rewrite that. But when it has a minus charge, it's going to be called fluoride. All right, so what about Cl? When we talked about the names of the elements, what do we call Cl? Oh, we called it chlorine, right? But when it has a charge, we don't call it chlorine anymore. It's called chloride. So negative ions are going to end in IDE. So these guys, when they have a negative charge, will end in IDE. All right, so O, what does O stand for again? The element O? That's oxygen. But when it's got a minus charge, a -2 charge to be exact, it's not oxygen anymore. It's going to end in IDE. It's oxide. And while we're at it, how about N? What's N called? The element N is nitrogen. But if you have a negative charge, you're not called nitrogen anymore. You're going to be called nitride. You're going to be called nitride. All right, so that's how you name negative ions. Negative ions should end in IDE. All right, so with that, let's just try maybe one more. Let's just try one more. All right, so let's make sure we got the hang of this. All right, let's do a little practice. Make sure this is making sense. So questions are going to pop up here in a minute. You're going to need to answer. All right, so let me put them up first, though. So question number 1. What will be the charge on sulfur when it's ion? And when it's an ion, what will be its charge? Sulfur is right here. What will be its charge? Okay, second one. When it has a charge, what are we going to call it? What will be the name of sulfur when it has a charge? Okay, hopefully that went okay for you. Hopefully you got those two right. I hope you did. All right, so that's it for naming ions that are coming from nonmetals. So in the next video, we're going to talk about what do you do when you have a metal forming an ion. So that'll be part B of this series. So let's scoot on to that.